Good morning, good afternoon, good evening, everyone. My name is Zhao Ku. I'm a senior research fellow at IFPRI, and it's my great pleasure to welcome you to today's webinar. Today's topic is how can we improve global crop mapping, IFPRI's spatial production allocation model called SPAM. This is the fifth event in the webinar series on IFPRI modeling systems, informing future pathways and priorities for agri-food systems. This series is co-organized by IFPRI and the CGIAR Foresight Initiative, and it is intended to provide an overview of some of the tools we use to look at various aspects of the future of food systems. During this webinar, our presenters will showcase SPAM data and product within the broader context of global cropping system mapping perspective and history. We will discuss key challenges and insight on the future of improving the global cropping data product. And now, it is my pleasure to introduce our speakers. First, today's webinar will be opened by Professor Navin Ramankoti, Professor and School of Public Policy and Global Affairs and Canada Research Chair at the University of British Columbia, Canada. And we have the presentation will follow by Liang Yu, who is Senior Research Fellow and Foresight and Policy Modeling Unit at IFPRI. And we have two discussants, Deepak Ray from University of Minnesota and Christy Slay, CEO of the Sustainability Consortium. Before I hand over to Navin for his opening remarks, I want to share a few notes on how we will proceed. The presentation will last about 25 to 30 minutes, with the rest of the time dedicated to questions and answers. Please feel free to send your question via the Q&A window at any time during the webinar. We will do our best to answer as many questions as the time allows. When you ask your question, please let us know who you are and where you are from and what organization you represent. And finally, we are recording the webinar today. We will make it available on our website, IFPRI website, shortly after the live event ends. And yeah, finally, I'm pleased to introduce Professor Navin Ramankoti, our opening speaker today. Navin is actually someone who hardly needs an introduction in our geospatial circle. As a professor, and again, at the University of British Columbia, his research has been generating lots of foundational global land use and land cover data, among others, shaping our understanding of global agricultural systems. And his pioneering work in developing global data set of cropland, including the widely used global agricultural land data set, has become really instrumental for research in food security, environmental sustainability, and climate change studies. With over 50,000 citations to his work, he continues to influence policies and practices in sustainable agriculture worldwide. So with that, over to you, Navin, for your opening remark, please.
Yeah, thanks, Jao, for that very generous introduction, and to you and Liang for inviting me. So in my 5 minutes, I'm going to touch on two things. First, why global crop mapping, and second, also to briefly touch on the history of this type of work. So why do we want to do global crop mapping? Well, the first thing is that agriculture is the other inconvenient truth, as one of my colleagues calls it, in the sense that when we think about global environmental problems, we think a lot about climate change, but it's not as well understood that agriculture is also a major driver of global environmental problems. And that, in fact, even if you solve the climate problem, we are probably going to be left with the agricultural land use problem. For example, a third of our world's ice-free land surface is in agriculture. Agriculture is responsible for a third of the climate problem itself. It is the biggest driver of global biodiversity loss. It is also the biggest user of fresh water, and as well as the polluter of fresh water. So to solve our global environmental problems in the long run, we do need to be thinking about how we do agriculture and potentially transforming it. But at the same time, agriculture is the critical source of human nutrition, as well as livelihoods for lots of people, especially in developing countries. So we have to address this kind of challenge of providing nutrition and livelihoods for people, while also addressing global environmental impacts. And that's where global crop mapping comes in. Such data are critical to both global and regional analysis of agriculture's environmental impacts, but also for mapping and assessing and mapping out development opportunities and development pathways. I think the description of this webinar itself, touches on some of those applications very nicely, and I think we're going to hear from the remaining speakers on that as well. So next, just a brief history. One may think that such global crop mapping work is recent because we have all these easily available data sets now. But on my bookshelf in my office, I have a book titled Geography of the World's Agriculture that I found in a used bookstore a couple of decades ago. It contains maps of agriculture, not entirely clear how the information was compiled, but the maps are really fascinating. It shows maps of crops and animals around the world. And it was published by the US Department of Agriculture in 1917. So there is at least one example of global crop mapping from more than a century ago. So that such work has fascinated people for a long time. Now, if you fast forward to the 1980s, the NASA global climate model was being developed, and it was looking for global maps of the world's land use to use as kind of inputs to the climate model. They had a geographer on staff at that time, Dr. Elaine Matthews, who painstakingly created global maps by visually examining what are called operational navigational charts. These are charts that pilots use when they fly around the world. And she manually coded these charts she examined the charts visually and manually coded them to create these global maps. It was incredibly intensive work and tedious work done over several years. But then in the 1990s, so the dawn of global satellite data and our kind of technological advancements in geospatial mapping kind of really revolutionized this kind of global work. My own PhD work back in the late 1990s exploited such data. But satellites can only see so much from space, and even though their capabilities are dramatically improving every day. So some people started blending both satellite data as well as ground-based data to create better spatial products. My own initial work, again in the late 1990s and early 2000s, was a crude approach. And that's when I found out about the ongoing work at IFPRI. Liang, who will speak next, was a brand new scientist at that time at IFPRI and was working with Stanley Wood. And they had developed this fairly complex model to take subnational census data on agriculture and spatially allocate them to pixels using a really complex set of decision rules. It was really groundbreaking work at that time. And Stan Wood, he's British, so with his sense of humor, he named the model and data set SPAM. Some of you will get that humor. But that early work has led to the continuing SPAM dataset and product. It's improved dramatically over the decades. And let's now hear from Liang about this remarkable datasets and its continuing evolution. Thank you.
Okay, thank you. Yeah, indeed. Yeah, I also cleaned my office recently because IFPRI, we have been kind of reshuffling our office spaces. I also found in my bookshelf kind of dusted all the atlas of national crop production statistics around the world. And yeah, I do share that the sentiment. There's a lot of work. The previous historical work went into the blooming of this kind of groundbreaking satellite data fused different kind of data set we are seeing today. So I really appreciate having your opening remark and also your work just on behalf of all the global crop mapping and agricultural mapping community. Your work has been really inspiring and instrumental to the place where we are today. So really appreciate. Yeah, okay, so then moving on to our main speaker of the day, Liang. And yeah, as Naveen said, the name SPAM is not from Liang, not from us. It was from our previous colleague at IFPRI called Stanley Wood, who is now enjoying retirement somewhere in Europe, I hear. And yeah, so Liang has been also very instrumental to making the vision of spam reality has been continuously or tirelessly, publishing new data set and a new publication, and also kind of promoting this data set across the global community. Liang's research combines such innovative spatial analysis with also economic modeling to address a lot of complex research questions around agricultural productivity, food security, and sustainable development. So I'm really pleased to introduce Liang as our main speaker of today. Thanks. And Liang, go ahead.
Thank you, Levin. Thank you, Joe. Please, can you put the slides on? Yeah. So thank you. Before I go, so thank you. I echo what Joe said. Levin, the pioneer work you did today. Instead of go to next slide, please. This is IFPRI and CGIAR spam model. This is in terms of very complex. I'll have before I go to a little bit detail on Botswana. Just say this. So today we are trying to be not complex, talk about the technical issues. So I'm more interested in this process usage of this, how this data set is used and how the process produces a model, and uses the latest, just uses the latest spam 2020 as the I've kind of focus on that one as the example. I promise you, there's no equations. So if you want equations, just go to the website. Website of mapspan.info. There's a lot of publications, equations, and also data set stuff. So you can go detail. In terms of the name, I think both Joe and Levin, you touched up the names. I really like spam. Spam is a name. It's just literally is the kind of the first letter of this spatial allocation model. But if you go to the reverse of word, it's maps, right? So in the sense, if you don't like spam, just think maps. Go to next slide, please. So for that one, I would just Levin also give a good introduction to why we need it. So I don't need to go to the usual why we do it. But here we look at this spam model itself. What it does is basically estimate the spatial distribution of 46 crops. Native one, we have 46 to 50 crop types we are talking about, and basically area production yield at pixel level globally, each pixel. By discrete data for coarse units. For example, as Naveen said, we have this national, subnational data, but we want to go to a little bit of details. Use entropy-based model. Again, I don't want to bother with equations, but think about data fusion approach, and combine a variety of input data. I will talk about what kind of individual input data, tabular, polygon data, and spatial raster data. Also, I think it's unique to spam. Maybe it's other. We also got crop assistant. Crop assistant we mean very simplified, like a rain-fed irrigation. Most of the globally, we are talking about is 10 kilometer, 5 minutes spatial grid, and the country level will go to 1 kilometer. Temperature. This is also unique for spam. We actually over the years, as Joe also mentioned, we are trying to do it every 5 years. The latest is 2020. I think hopefully we'll go to 2025, maybe. The statistics always a little bit delayed, so we are not delayed. Go to the next slide, please. So here is the main kind of input data. I think it's more or less, if you look at other kind of allocation model similar. So the base, I want to talk about the basic data, national, subnational production data. This is most of the subnational. Basic, it's just basic area and yield and production, right? And a little bit on the second one, on the crop assistant, the irrigation rate, I said it's not just unique. It's kind of we have a modern approach. We are go to a little bit deeper, not just rice area, rice yield. We can irrigation rice versus rain fertilizer, for example. And then we have this crop suitability. This is a lot of you guys maybe already know Global Ecological Zone Project. This is a zone from their suitability, most of the potential side. Cropland extends this from a satellite. Cropland, as Levin already mentioned, is not even nowadays. It's very hard to get the crop types mapping out by satellite, but the cropland, overall crop extent is possible. Irrigation area, crop prices, and the crop intensity and the population distribution. This is also maybe if you go to the model, this is also a model input. Next slide, please. Yeah, this is a figure basically. So if you look at the left, from the left side, the first figure, you can see, if you go to some kind of geography, you this admin unit, you'll see, this, you don't know where exactly this crop growing. So we'll go from the started with the subnational unit, and then and we go to the satellite, imagery, go to kind of cropland, the kind of extent, just focus on cropland. We aggregate the cropland with crop suitability and population density, and even in the middle, you have this item D, I think, share of irrigation or not. This is where we want this rainfed irrigation. And then you put everything together into a modeling, this is where the entropy comes in. And you'll see the figure on the bottom left. This is, you can see, compared to the bottom upper figure, you can see, we can see it clearly. The crop is only focused on a few kind of tiny spot within this whole admin unit. Next slide, please. So it's output. Basically a spam output is produced for now, of course, it's a native 46 group. Also, it's not crop types, also crop group. Like, for example, I'll have a list of the crop types. Some crop vegetables, for example, is like a group, right? For crop, 3 crops in 4 variables. The variables, you can see variables. This is for every pixel in the world, every pixel in the world. So this fixed area, harvest area, production, and yield. Maybe you notice the physical area and the difference between harvest area. If we have double cropping, obviously, physical area is only half of the harvest area, right? Crop density means, as I already mentioned, is total. Also, we want distinct irrigation and rainfed. For example, if the area part also yield, particularly maybe in the same location, if irrigation yield maybe a few times higher than the rainfed yield. Next slide, please. Yeah, so here I go a little bit, as I promised, I go a little bit detail on if spam 2020, what they talk about, what kind of input data you are using. For example, of course, subnational data, normally we call 2020 is a circle 2020. We are, to avoid a typical year, we always take some kind of average between 2019, 2021, of course, depend on the statistic, the data availability. We have, Foresight, of course, this is national, but most of this case we use subnational data. This is where around this 2020 years. Cropland extent, of course, I can talk a lot about cropland. Actually, we use hybrid because just take one, for example, global land, 20, or even the European Space Agency world cover. Then you also have some bias. Some land product have good in one place, some good in the other places. So we'll have kind of hybrid approach. This is another, we are working with a lot of remote sensing experts to produce a hybrid. We think around the year we want to focus on more or less in the we think is the best, available, for each for the cropland extent. Irrigation area, we actually harmonize two map, global map irrigation area, also global irrigation. The first one is by FAO, and then the second one is by, this remote sensor based by our sister CGIAR centers. Suitability, as I already mentioned, global AZ. Population, we actually also use population because the price, is important for us to allocate crops. Market access, again, is related to get the spatial explicit price. Next slide, please. Yeah, so now I think it's a little bit more on the major update. As Levin said, we started, I was as a fresh PhD student, came out of school when 20 years ago we started this work. And this is a huge kind of evolution over the years of the methodology. I think there's a lot of things new. When to be maybe embarrass myself, when we started, we used FoxPro. I think nobody used FoxPro program language, even Microsoft discontinued it. So nowadays, I think we are very glad now the news spam is free open access. We just opened the whole source code of spam on the GitHub. This is GitHub website, and then they have now, you can have run your own spam on the GitHub. I mean, of course, it's not that easy, but if you do some work, I mean, we open the whole source code. We have two kind of versions: spam, global spam country. So if you're interested in some country level kind of allocation, you can do it yourself. Another is you can select crops. For example, globally you have 40 somewhere. For your country, you only want 20 crops is possible. And then you also can adjust the kind of spatial resolution. Globally, of course, you know, it doesn't make sense to go to very spatial, smaller scale. But if you locally, you can go to 1 kilometer, even smaller. You know, of course, it's a little bit experimental. This is where I put it there. Actually, on the right-hand side of the map, this is for the country level. This is, you can see this is 1 kilometer resolution maps. Yeah. Next slide, please. Yeah, this is crop list. I guess I would say, you know, this, you know, covered almost 90, you know, over 95% of cropland. We even have the rest crop. This is four red, kind of, we put in the red, just citrus, tomato, onion, and rubber. It's the latest addition for the SPAM 2020. I mean, over the years, we started with 20 some crops and then we increased. But over the, I think it's a major crop is continuous over just 20 years. Next slide, please. Yeah, again, you know, again, every people ask, you know, of course, as Levin also said, there's no global map for you to compare, right? You know, so what do you, how did you validate your things? Yeah, so we actually rely, you know, the first step, because we are the CGIAR centers, right? We have a lot of centers, scientists all over the world. We actually feed from CGIAR and also the local partners, right? And the audience like your guys also using this, the usage actually can help us. It's I mean, it's not rocket science. Even high school students, they can, you know, they can look at their backyard. Oh no, my backyard is not growing rice; it's growing maize, for example. You know, you can actually, even your local is not that much kind of high tech. And also we use also Levin also touched about that one on this. We have latest satellite data, for example, the soybean map, you know, for the Americas, and then there's a sugarcane map, global sugarcane map by Stanford University. This will also have kind of sources. Of course, we, as I said, we also do our own validation. You know, SPAM website. You have some nowadays use the new technology. We even use GeoWiki. Did with YASA, you know, trying to get some validation by crop type maps. Next slide, please. Yeah, and then another question, also feedback from the, so how sure, you know, how confident you have on our estimation? So it's very hard, as I said, to a kind of systematic validation. So what we did in the top map, actually we get, you know, it's only country map. We depend on the, again, a lot of, if you look at how SPAM is made, is, you know, is kind of subnational data actually play a big role. So if how much subnational, if you have very good subnational data, you know, you know, you don't need the very sophisticated model. You already know the distribution, right? So if you can imagine, so we use some kind of subnational data as the major driver and some other kind of model, modeling kind of inconsistent approach. We win the model. We give a more or less the top of confidence. You know, one is the lowest voice height uncertainty map, by the way. You know, you can imagine, you know, not surprised, a lot of African, you know, and then some countries is the uncertainty is very high, right? You know, that's radical. And then another, of course, you know, another way to validate is, you know, we this is what we normally do, validate the model, right? You have a high resolution, for example, level 2, you know, county level data. You don't use it at first. Why don't you just use your provincial level 1 data to allocate it to the area and production to the pixels and aggregate up to the level 2, the county level, and then compare. I mean, the bottom figure actually showing this is a comparison on the admin level. Next slide, please. Yes, this is just show the maps, a few maps for latest SPAM 2020 map. This is wheat, rice. Next slide, please. Yes, this is wheat and rice again. This is, the first slide is area, now is the yield. Go to the next slide. Yeah, again, you know, this is actually, I want your guys to just, we do have a SPAM or dedicated SPAM website. This is going on for many years. You know, this started from, as I said, I think we created 2009, 2008. So everything is here. You have the latest development. Even you want feedback, you can do the feedback. Just a few years, I mean, every 5 years from 2000 to latest 2020 SPAM dataset, the methodology, and even some publications, SPAM related publications, some other usage cases there. So I encourage you guys, you know, to go there to get everything. I mean, today as I promised, I didn't talk about technical details. Again, you can find quite a few spam related methodology papers over the years. Next slide. I just want to show there. So it's now for those of you who just just users, you don't want to go details. You can just map it. Zoom in, zoom out with Google Earth Engine. If you can see on the left side, you have 2000. You can select which year you are looking at, which crop you are looking at, which variable you want to map. This is all the variables here. This thing. Okay, next slide, please. Yeah. Here is also showed, this is showed this is the download from, we have you also put it on the Dropbox, and then also here's the website. This is data format. As I said, we have CSV for those of you want to use your own application. They also have GOT files, and also by you can imagine this thousands of files, right? Variables as variables, area, yield, production, so many crops, crop system, and global by pixels. Go to the next slide. Yeah, here just for example, this is what the usage looks like. So there's a map showing where it's downloaded. This is because Dataverse actually try kind of trace the how many downloads you got, right? So this is some statistics from Dataverse, and of course you don't need. Dataverse is not the only source you download. You can download from our website itself. Also, this is a direct go to our Dropbox. So even the Dataverse account alone, you can say it's a download. So for it's the most popular way seems like 2010. This is 2010 is almost 56,000. The latest 2020 is of course just published like early this year. So we will again. I want to emphasize, over the years, because of your feedback, we have different kind of versions. For example, 2020, we are going to release 2020 version 2 early next year. So over the your feedback and the things, the new things we found, we also have the version kind of update of on the same website. Next slide. Yes, the usage. I think that Christy will talk about how to use it in her application. But I would say a lot of it is IFPRI CGIAR itself, because this is more like a demand driven. We go into this doing this once because a lot of our own demand. Also, there's at least some project organization like AgriDev and this farm, and even our IFPRI's own impact model, and there's models like GeoGlam. If you look at lots of Harvard programs impact our models, and also used a lot of our own application and also global modeling communities. I just came from this global land program. There, there's a lot of users, they'll actually see this is, as Levin said, this is kind of the gap. If you look at the global set data set gap we are filling in. Next slide. I hope it's yeah, this is feedback again. I encourage you go there. If you have feedback, just let us know. We'll actually treat feedback very seriously. We'll just look at every feedback you have. Next slide. I hope it's the last one. Yeah, again, this is spam community. I want to thank you all the donors, from the Harvard Choice days with Bill Melinda Gates Foundation, and nowadays with II's Land and Carbon Lab, and also particularly, all the individuals. You can imagine all these things. It's only partially listed people who actually doing a lot of detailed work. Connecting this subnational data, get the boundary right, link to the data, and then check why this yield is so high. And then of course the feedback from users from all this we call it spam community. That is where go back to the geography spam itself. We really want this a spammer. Liang would be the master spammer. I think this is our last slide. So go over to you, Joe.
Okay. Yeah. Thanks, Liang. Yeah, indeed, spam is a community. Spam has been really a leading global community on this type of global crop maps. I mean, there are other types of product aiming for similar objectives, but yeah, spam has very unique place in this global crop mapping community, because we start from subnational statistics and we are driving to the ground truth data and also matching with the statistics data from all of the countries. So there are a lot of different types of approaches and innovation going on. So yeah, we will have the time to discuss after the presentations from our two discussants today. So I see some questions coming up, kind of asking for more details in this kind of methodological approaches. And just rest assured that we will have plenty of time to discuss on that. So please feel free to continue entering your questions. Okay, so let's go to our the two discussants, starting from Deepak. So Deepak Ray is senior scientist at the Institute on the Environment, University of Minnesota. And Deepak's research has been focusing on documenting historical yield trend and analyzing climate sensitivity of major crops, among many others he's been doing. And Deepak will show us kind of complementary approach to speed up the SPAM process. So really excited to hear your progress, Deepak, and over to you.
Great. Thank you, Jim. Can I have my presentation up, please? So I am going to talk briefly on how we can improve the accuracy of global crop mapping, essentially how we can shorten the time in making better quality maps. So next slide, please. So if you want to take anything away from my presentation, it is like, it's written right over here. Bring the satellite-based approaches, which have improved tremendously, and the statistical approaches, which have also improved tremendously, but not essentially talking to each other, and bring them all together. So in some sense, this is a low-hanging fruit, and bring the advances of both the satellite approaches as well as the statistical approaches like the SPAM modeling techniques together, and resulting in a much more improved mapping. So next slide, please. So this top panel shows like how the remote sensing approaches generally work. You have a satellite which is observing a piece of real estate, and you have the reflectance energy going back to the satellite. You also know, if that is what the label means, what that piece of real estate is actually observing. And then you have an algorithm to detect other real estates having the same kind of signature reflected back to the satellite. So when you do this all across a large area, you can then identify what is essentially the crop type. So the critical piece is, of course, getting the labels correct. So that is also a limitation because it is very expensive to get those labels from all across the landscape. But the advantage, on the other hand, is that as satellite spatial resolution is increasing, if you are successful, then you get very high resolution crop type maps. And this is far more higher resolution than what we can achieve by using statistical approaches. So can you press the bar, and we'll see the bottom part, which shows the statistical approach, which also has a cropland information, which Naveen mentioned and which Liang also mentioned. And with that, you have like a huge quantity of subnational administrative area information. And then you run an algorithm like, say, a SPAM, and you come up with the crop types. So there is a challenge in the remote sensing, which is the labels, and there are advances taking place over there. And there are challenges in getting subnational crop statistics, but that is also improving tremendously. And if we can harness both those together, then we can make tremendous progress in improving the spatial resolution and accuracy of crop type mapping. Next slide, please. So here I have zoomed to the Central Valley of California and showing a data product from the United States, which is called the cropland data layer. The vast area outside of the Central Valley, which is very colorful, is all these green areas, which is the natural landscape. These cropland data layer is at 30-meter spatial resolution, which is the Landsat resolution. You have some red colors, blue colors, magenta colors, and yellow colors. The yellow colors in this Central Valley of California is where corn is harvested. There is either a single season crop or there are double crops with soybean, barley, or any other kind of things. In the past, the cropland data layer used to use Landsat data to build these crop type maps. And more recently, they are using the Sentinel imageries to bring the crop type map using techniques like what I mentioned in my previous slide. So can we then use this kind of information from satellite remote sensing to guide our more coarser resolution mapping of crop types, and in which is based off using census or survey information from individual countries? So next slide, please. So if we are able to use that information of where the corn is, then you can the administrative units which reports that there is corn harvested in the United States, you can more accurately figure out where, using remote sensing and fusing them together, where exactly the corn density is, the highest harvested area, or more of the grid cell is harvested. So I've not shown the legend over here, by the way. So the green, higher the green color, it means more of the grid cell area, which in this case, if you remember from Liang's presentation, at 5-minute grid cell spatial resolution, how much of the harvested area is in corn. So more green means more area is harvested. More towards the red means less area is harvested. Now, go to the next slide, please. If we had only, say, the cropland information, then using the admin unit or administrative information of how much corn is harvested, you will still be able to map accurately enough the counties or the districts. In the United States, it's known as counties, which is a sub-state level information of where the corn is. But when you bring the remote sensing crop type maps, that is the corn location, then the location is more accurate. Now, what the SPAM modeling has to work extra hard on and spend a lot of time is how you go from this administrative unit of where the cropland is and where potentially corn could be, to mapping, to going to the previous slide, which is where the corn actually is. So that entire process can be speeded up by harnessing the power of those who are already making advances in remote sensing technology. So if you go to the next slide, when you take the cropland approach and you map the whole of the United States of where the corn harvested acres or hectares are, again, I've not shown the legend, but more deep, the green color, that means more of the grid cell is covered by corn, and the more towards the red, it is less covered by corn. And then if you go toggle back and forth, this is the map using just the cropland information. And if you go to the next slide and you then toggle back and forth between this slide and the previous slide, when you have the corn information in the more outer areas, you are able to map the corn more accurately using just harnessing the power of remote sensing and the remote sensing community, which is making progress. There are many challenges, of course, in this. Both both approaches will give you the same kind of map in the major harvested area. So you see in the corn belt of the United States, it's all green, mostly in both the approaches. Either you use just the pure statistical approach or you use statistical approach with the remote sensing approach. But when you go to the outer areas, the less harvested corn harvested area, then you have a little bit of more challenges. There are many other challenges of remote sensing based approaches also, which these are all, a continuous development process. But what I'm trying to say is you can harness the power of the remote sensing to make progress where remote sensing has made progress. The challenges are essentially where the landscape is far more complex. There's much progress to be still made. So if you go to the next slide, and this is my final slide, there is, of course, one more thing which remote sensing cannot yet provide us. And this is the crop yield information, because just the crop type mapping is not sufficient. And as Naveen said, and Liang said, we need harvested area as well. So crop type area, harvested area, and you also need to know the productivity. And I have also not mentioned how we can use the statistical-based approaches to inform remote sensing, to improve remote sensing-based approach of crop type mapping. I want to end and hope that I have convinced all of you that there are opportunities to harness the strength of both the remote sensing approaches and the statistical crop type mapping approaches in the interim period while remote sensing approaches become even more advanced. And I'll pass it back to Jaibu. Thank you for your attention.
Okay. Yes, thanks so much for the presentation. You're really exciting, all these advancements. Yeah, as you said, the remote sensing-based approaches are evolving, and there are many ways that we can fuse all these different type of approaches for better and more accurate and faster processing of this new data set. So yeah, really exciting. Yeah, thanks for presenting that. And I'm sure we will have more time to discuss more details about what can be done to bring all this innovation to SPAM and also collaborate together further. Great. And then our next discussant is Christy Slay, who is the CEO of the Sustainability Consortium. And the Sustainability Consortium, or in short TSC, aims to transform the consumer goods industry through green technologies and sustainable practices. And TSC develops, among many other things, they are doing also science-based metrics and tools that help companies measure and improve their environmental and social impact. And Christy will show us today how SPAM, along with many other global data sets, powers one of the TSC's new tool called Commodity Map. So it's really excited to see how it works and what it is. Over to you, Christy.
Thank you, Jaiwu. Hello, everyone. It's great to be here. I'm Christy Slay, CEO of the Sustainability Consortium. As Jaiwu said, we have a mission of all products sustainable. We're based at Arizona State University with offices at Wageningen University. So our goal is to bring science-based tools to business decision-making. And I'm going to share with you today a very exciting application of the MapSpam data and how we are using it to support business decisions with companies and retailers. And so just to give you a little history of this tool, which I think is really important, we started the Sustainability Consortium 15 years ago, and we were having a meeting with global food brands and retailers. And the number one barrier that they were reporting at that time was having transparency and visibility into their commodity supply chains. And they expressed that they couldn't make progress because they didn't know exactly where they were sourcing from. And I thought, well, gosh, that's a data problem. We can solve this. And so we immediately looked for global production data sets and quickly came across MapSpam. And then we started combining MapSpam with other data sets so that we could create a tool that would help to support this decision-making and knowledge that's necessary to make progress on agricultural sustainability. And so Commodity Map is a tool that we formally launched in May of this year, but it has been in beta for a number of years as we developed it and tested it with major brands and retailers. And then a couple of years ago, we received a grant from the Walmart Foundation to create a publicly accessible free tool. And so everyone can access it now. And so we're really excited to have this launched into the world. And I'll share with you a little bit more about this tool. Next slide. So Commodity Map, it covers the most likely environmental and social issues in regions where a company is sourcing its agricultural commodities. And so we use the MapSpam data sort of to underpin and identify where those crop production regions are in the world. And then we overlay environmental and social issues that might be facing a business supply chain and highlight those issues in areas where they need attention. Next slide. And so we cover over 150 unique food and fiber commodities. And so we use the MapSpam data in a way that there are highly aggregated commodities within the MapSpam data, and we actually disaggregate those to be able to cover the breadth and depth of what food companies and retailers are sourcing. Next slide. And so I mentioned we analyze key sustainability issues such as deforestation, biodiversity, water, child labor, forced labor, and governance. Next slide. Our data sources are here so that you can see we use leading NGO and research organizations in our commodity map tool. And so this is really a tool that has pulled some of the best available data and aggregated it in such a way that it's all in one place and can be overlaid. And so on the crop production side, as I mentioned, we use the map spam data. It underpins our crop production analytics, but we have combined it in a unique way with USDA FAO trade statistics. And so we have what we call our trade network model, where we've combined and linked the map spam crop production data with import and export data that's tracked by FAO. And so what that enables us to do is if a company doesn't know where they're sourcing from, they can use our trade network model in the commodity map tool to back into where they're likely sourcing from using those trade networks. And so what that does is really empower anyone, doesn't have to be a company, to really trace back through those trade networks to the production region where crops are being produced. And so we go back about 5 countries deep. And so as we know, countries trade with each other. And so just because you're sourcing from one country doesn't mean it was produced there. Oftentimes there are broker nations or there's other steps that are happening with different countries involved in different production regions. And so we can actually, the model actually backs into where that crop is actually coming from, aggregates that, and displays that for the user. Next slide. And so as I mentioned, it's flexible. And so if you know where you're sourcing from, you bypass the trade model in the tool. And so it just shows you where you're sourcing from and what those statistics look like. But if not, users can use the trade network model. And so they indicate on the front end if they know where they're sourcing from or if they don't. And that if they don't, it triggers the trade network model to be able to identify where those source regions are. Next slide. So this is some of the output for the commodity map tool. So I use bananas as an example. This is results from US-based bananas. So let's say I was a company and I didn't know where my bananas were being produced, but I purchased them. I'm based in the US. The commodity map using the trade network model and linking into the map spam data demonstrates where and identifies the geographic locations of where it's most likely that those bananas are being produced. And so you can see it's broken down by % of supply based on production and those trade networks. And so you can see Ecuador, Honduras, Colombia, Mexico, Peru, and you can see the percentage of supply that would be coming from each of those countries. And then you can also see the environmental and social issues that might be present in those supply chains. So again, this is a model. And so what it does is it enables a company or a user to take a next step and talk to their suppliers that might, to identify, are you actually sourcing from these regions? And for example, what are you doing about biodiversity in your supply chain? Because commodity map indicates that biodiversity is an issue in most of the countries where bananas are being sourced in this particular supply chain. And so it really does help a company to narrow down and narrow their focus and be able to have some of those conversations with their supply chain. Next slide. And so we also offer recommendations. So in addition to these dashboards to highlight at a very high level what the issues are, we have resources such as certifications or programs that can help with particular issues in particular countries. And again, map spam data is underpinning this. And so we layered on top, what are those programs that are operating for bananas and it addresses deforestation. It highlights those programs that a company or anyone could get involved with to improve the supply chain and improve that issue in that country. Next slide. So you can also go by country. And so with the source region of Costa Rica in this example, you can look at what are some of the issues that are known for bananas coming from Costa Rica, and then you can take a deeper dive on some of the agricultural practices. So not just certifications and business practices, but actual agricultural practices that could improve, in this example, biodiversity or deforestation on the ground. And so we really do have a wealth of resources in this tool to help support decision makers in kind of knowing what some of those next steps might be. Next slide. And so anyone can use Commodity Map, so I encourage you to come check it out. So share it with your teams and colleagues. You can use the website. Let us know what you think. And so I mentioned we launched in May, so we really appreciate feedback. You can volunteer to share your experience and your results. You can certainly help to support others making progress by sharing your experience with us. You can share it with people that you know might be struggling to answer these types of questions, whether they're researchers or companies. We have a variety of users that use Commodity Map. We have policymakers that are using it. And then we also are obviously accepting sponsors to support this, to keep it open source and keep it publicly available for the future. And we also want to continue to update it with new data as it becomes available. So thank you, Jay. I'll hand it back over to you.
Okay, great. Yeah, thanks so much. I'm really impressive. I remember, Christy, we met first time like 2019, like before COVID, and kind of brainstorming this kind of tools and what kind of data will be needed. Really impressive to see how it all came together. Yeah, thanks so much for presenting. Great. Okay, then I'd like to ask all the speakers to join me on screen to look at the questions that we have on the Q&A. So yeah, let me just go right to it. The first question is actually two questions from Christopher Muller. Hi, Christopher. Asking, actually, there are a lot of questions in those two messages. But let me start from this one to Liang. So why every 5 years? Why can't this be updated every year? And let's start with that. And then, yeah, you also asked some technical question around whether this can be open source so that maybe some other communities, other people can jump in and do it all by themselves. For example, the gridded crop yield. We also talked about how difficult it is to go from area to the yield. Yeah, so let's start from this year question, time lag question.
Okay. The bad it's just resource. I think it's just take a few years. Actually, now it's quicker as then. So the bad news is, this is just take time. Take on to connect. You can imagine connect all the global subnational data. I mean, the good news is actually we will have yearly, and Deepak and I get a grant through WIR from Bezos Earth Fund, produce the yearly global crop maps, but only for 25 crops. That would, I just alert, that will come. I don't know, I kind of promise at the end of next year sometimes, we'll have that will be. Okay, I'll stop here.
Yeah, and Christoph also asking, is there any plan for expanding the list of variables to include, for example, fertilizers and other inputs like pesticide that go together with this kind of production variables?
Yeah, maybe Deepak, I'll put you on spot. This is Deepak is now my partner in crime. So in that sense, Deepak, maybe you can address this one. What are your plan? Yeah, what we are doing.
Yeah, for fertilizer, Christoph, and for others, I have built like a time series of fertilizer application rate. Fertilizer data building is even more difficult than the making the crop type maps, at least at subnational scales. And even at national scales, it's difficult because the application rate information by crops is from surveys, which the FAO or the IFA, International Fertilizer Association, which is headquartered in Paris, they do occasionally. So it took me like 3 years of continuous work to kind of bring all data sets together to make a time series. But I'm happy to talk to you offline about more of this information of this time series of fertilizer application rate by crops and by time for every country of the world.
Okay, great. And moving on, the next question is from Sarah Lauder. Oh, hi, Sarah. So another very famous person in our circle. If you have seen any number of how many smallholder farmers out there, yeah, likely the number is coming from Sarah's paper. So thanks for coming, Sarah, joining us today. She's asking whether SPAM is looking at actual yield or potential yield. And there are some other following questions, but yeah, let's start from that. Liang or Deepak, are we looking at actual yield or potential yield?
No, actually, this version is actual yield. We are trying to actual, and then we are, as with the methodology it is always consistent. We are actually for each pixel, if you do a aggregation average about the unit, the atom unit is always consistent with the statistical, more or less consistent with the statistical.
Right.
exactly.
as long as statistics is describing the actual yield, disease actual yield.
Actual,
Yes. And so, and she's also asking what organizations, or if any, collect maps on crops that are used in producing narcotics like opiums, etc. And again, this is a problem. Let me just quickly say, I don't know what organization that might produce such map, and if any of the panelists, if you know. But yeah, we are sticking, our starting point of spam process is the statistics data. So as long as there's statistics data, then we could look into how we can, disaggregate that data. But I doubt there will be like trustworthy statistic data on narcotics. Anybody knows any information?
Yeah, some countries do report their like
Did you?
opium production and where they are mapping opium. So it potentially could be mapped, and I have come across such data, but maybe Naveen knows. He has a long history. Maybe he came across narcotics information in the past. I don't know.
No, I mean, I know of some people who are working in particular places with conflict and trying to map, illicit crops, but it's not something that's available in the form of statistics. You'll find literature on it.
Right. So yeah,
I came across like from some Afghanistan, like opium. That is when the US was still in Afghanistan. And I can't remember if opium information production from India or Bangladesh or other places are present or not. I may have come across, but I don't remember right now. But Afghanistan, I remember for some years there was some information.
Okay. So yeah, so that might give you some ideas, Sarah. But yeah, that's not within the scope of IFPRI's spam work, just to be clear. But yeah, thanks for that very interesting question. The next question from anonymous attendee asking, okay, spam already use satellite data and complex algorithms. What new kind of data and method could be used to enhance spam? What about AI? So I think that Deepak, you kind of touched that a little bit more. Maybe you can elaborate a little bit more.
Right. So with AI technology, you can, process huge quantities of data. You can have your statistical model, which can be like billions of model for every grid cell, and you can train it and then apply it. But the problem with AI is again the label. Suppose you train your model in the United States for say rice. Now you take that same model and apply it say in Vietnam. It will not work very well. So because the field is very, very different, but yes, it's a matter of like tremendous amount of research. And that's essentially what I was trying to touch upon in my presentation, that there are some crops and in some countries and areas, and the spam, the presentation of Liangji also showed like the sugarcane maps and other like the soybean maps in different places. When it is monoculture, it's kind of easier to map using AI technology. It speeds up and it's very, very accurate potentially. And so we can harness that power in our spam modeling system or just like the crop type mapping. We still need to go to the yield. That's another issue. Maybe Naveen can say, what does he think? How we will approach that in the future? Sorry to put you on the spot, Naveen.
No, I'm not really been doing this kind of work recently. Yield mapping, of course, you can try to use satellite data again to map productivity. We've tried to do some work like that in Canada, both to estimate yields, but also trying to forecast it within season. There is that kind of work going on in many regions of the world. David Lobel has a model called Scalable Crop Yield Mapper that's also trying to map yields. But I haven't seen anyone do it globally yet, but there are advances. I think probably within a few years, you'll probably see that coming up.
Okay, just a couple more minutes left, and we have 2 more questions to go through. So let's go through that just quickly. First thing is from Leonid asking about water. What extent water availability and water use have been incorporated into spam? So maybe Liang.
Okay, yes, spam. not explicitly, but the SPAM does distinguish irrigation. Remember, we have an irrigation map of the world. In that sense, water is standard. So we are not actually mapping irrigation. So actually, you can calculate irrigation water use, for example, through kind of reverse engineering, right? We are not again, our main job is also very complex. It's big challenge to get the map of the crops, right? So we are not going into the water use. This is maybe it's not after kind of post modern post mapping approach. Yeah.
Right. Yeah. Okay. And then finally, Kian is asking about how the early ground truthing is done. I think also Liang presented briefly as part of the presentation, but Liang, maybe you can just quickly give a high-level overview of the ground truthing
Yeah, I
and
think it's not.
validation.
Yeah, it's not systematic in the sense. I mean, the good old days. This winter we have those Joe. You should know what we call the commodity parties. Yeah,
Yeah,
maybe you can explain that.
mapping parties. Yeah, yeah.
We'll just go to, for example, go to, I don't know, make it up, Kenya. We have to, as I said, it's not if you're local agronomists, they know their distribution. I just show the map on the wall, and they said, oh, that distribution is terrible. No, we are not growing, growing maize here. Just more raised on this side. All this man-made. Nowadays, actually we tried to do this. Crowdsourcing is a huge one. We are, as I said, we are trying to harness the new technology. If you look at the YASA's GeoWiki, we are trying to put that on GeoWiki. You can actually map. Oh, that is not correct. I mean, area as area and the crop type area side is a little bit easier because it's just just look out your window, right? Yield is a little bit harder. So this is where a approach kind of validation what we did in the beginning. As I said, we just let them how the model run is just use the higher level, like just use the provincial level data, allocate to the peaks and aggregate it to the county level, and then compare it to county. And then sometimes we have the labels like what we had for US, of course, your CDL, you can compare. So it's not a kind of systematic, but whatever the data we have, we will kind of validate it in a sense.
Yeah, exactly. Whatever opportunity we have, we always try to engage with common users and other partners to validate our product at different levels. Actually, that brings to our last question to Christy. So you have in our discussion show us how your organization has been using SPAM data. Like, is there any feedback or any suggestions you might have as a prime user of this data set moving forward?
Oh goodness. Yes, I mean, I think some of the needs that we have are just around obviously extending crops, which I know you all are working on. And but primarily, I mean, the work that you all have produced it supports tools like ours very well. And so, I think I wouldn't actually suggest anything other than like expanding the scope of the crops. You all have done an excellent job. Yeah. On the AI question, I did just want to mention that another project that we've been working on with WRI and Google has been using deep learning models to identify and train the computer to identify commodity-driven deforestation and smallholder-driven deforestation. And so we're going to be hopefully publishing that very soon. And so there may be some of our methodologies that would be useful for furthering these types of applications for crop identification as well.
It sounds very interesting. And also again, exciting innovation starting from this crop mapping to all these different type of applications. Okay, great. Thanks for sharing. All right, so we are a few minutes past the planned webinar time. So I guess I think it's time for closing. So thanks so much for coming today. Maybe I will let Liang you just give us a closing remark and over to you.
I think I don't want to drag you into it. One thing, as Christy already writing, we are expanding the crops, and Deepak also mentioned a little bit on the future, I think the one thing I wanted to advertise, we will have the annual map probably by the end of this year for limited crops. But another kind of thing, I think in game, another dream, if you like, of my dream, actually, Joe was and you also, we want to go to almost real-time mapping. Remember, right now we are kind of global mapping, this year is now we are end of 2024, right? What we are talking about? Spam 2020. This is the latest. Yeah, I think it's way, if you learn anything from COVID, right? Of course, we are working from home more nowadays. But one thing is real time. Sometimes, if another COVID come, it's not our kind of normal. Or you go to the field, connect your data, come back doing this. No, that is not. The technology is there. That is where I think a lot of things. We are not in the promise land yet. I think deep algorithm mentioned, but how did you get almost real? How to get it? Chris already mentioned it's expanded crops. Of course, we are expanded crops, but even go to the time. I mean, of course, this is where remote sensing technology and then the new technology comes in, right? We have the tools, but how did you harness the technology? Even of course, we are limited by the delay of this statistical data. This is our approach, right? But how did you use the statistics data and use the AI or use the newer tools to have almost or not real time, I would say, real time, but almost real time. This is what I'm trying to say. That would be really, for the whole community, would be huge kind of leap forward.
Yeah, excellent. So very much looking forward to that. If you go to SPAM website, you can see all the publications, not just actual data set. So you will see a lot of innovations and different type of research is going around this topic. So please follow us. And okay, with that, thanks so much. Thanks all the speakers, panelists, and discussants joined today, and thanks everyone joined today for the webinar. So really exciting the progress, and we look forward to seeing you again maybe next time we present SPAN progress next year. So thanks so much.